Let's discuss how to multiply two series together. Suppose we have two power series given by the sum from n equals 0 to infinity of c sub n times x to the n, and the sum from n equals 0 to infinity d sub n times x to the n, and suppose these series converge to f and g respectively on some interval I. In addition, let E sub n be the sequence defined by c sub 0 times d sub n plus c sub 1 times d sub n minus 1, and so on, out to plus c sub n minus 1 times d sub 1 plus c sub n times d sub 0. We can also write this as the sum from k equals 0 to n of c sub k times d sub n minus k. Then we have two results. The first is that the product of the sum from n equals 0 to infinity of c sub n times x to the n and the sum from n equals 0 to infinity of d sub n times x to the n is equal to the sum from n equals 0 to infinity of e sub n times x to the n. The second is that the power series given by the sum from n equals 0 to infinity of e sub n times x to the n converges to f times g on the interval I. What this means is that the product of two power series is also a power series, and the new power series converges to the product of the limits of the original two power series on the same interval. The resulting series is known as the Cauchy product of the two original series. Now let's multiply some power series. We have the series given by the sum from n equals 0 to infinity of the square root of 1 plus n, and we have the series given by the sum from n equals 0 to infinity of 1 over the square root of 1 plus n. The binomial series for the square root of 1 plus n is 1 plus n over 2 minus n squared over 8 plus 3 times n cubed over 48, and so on, following this pattern. The binomial series for 1 over the square root of 1 plus n is 1 minus n over 2 plus 3 times n squared over 8 minus 15 times n cubed over 48, and so on, again following this pattern. We can see already that the product of these two functions is going to be 1, because the square root of 1 plus n terms would cancel, but let's verify this in a different way. We'll multiply, collect like terms, and simplify to verify the result. Setting up our equation, we have the square root of 1 plus n times 1 over the square root of 1 plus n is equal to the quantity 1 plus n over 2 minus n squared over 8 plus 3n cubed over 48, and so on, times the quantity 1 minus n over 2 plus 3n squared over 8 minus 15n cubed over 48, and so on. Multiply and collect like terms. When we multiply these series, we want to do something almost like foiling, so that every term is multiplied together. For the constant term, we have 1 times 1, which equals 1. For the n term, we have n over 2 minus n over 2. For the n squared term, we have 3n squared over 8 minus n squared over 8 minus n squared over 4. For the n cubed term, we have negative 15n cubed over 48 plus 3n cubed over 16 plus n cubed over 16 plus 3n cubed over 48. We can see here that each of the terms after 1 equals 0, so we are just left with the constant term, 1. Therefore, we have verified that the product of the two series is 1.